Awesome. Thank you, Brent, for introing me and kicking this off. Thank you all for coming today. My name is Chris Munns. I'm currently, let's see if I get this to work. Just turned on. There we go. I'm currently the senior and lead developer advocate for serverless here at AWS, actually also based here in New York City. We are unfortunately not talking about serverless today, which is my normal topic, but we're going to be talking about production readiness and what that means. And so I've been here at AWS for a little over 5 years. That's why I have this gold employee badge. That's what you get for 5 years. It's exciting, right? Yep. But before this, actually came from the startup space. So worked in operations teams at Etsy, at Meetup.com, a couple other startups that I was part of over the years, and consider myself much more of an infrastructure and operations person, despite my move into the serverless world just shy of a year ago. So really kind of the genesis of this talk, or one mind frame to put yourself into when we're thinking about this talk, is a phrase from Murder Verbals, who's CTO here at Amazon. It's that everything fails all the time. And when we talk about failure, we're not just talking about a hard drive dying, we're talking about an individual server going down. We're talking about kind of the broad spectrum of your infrastructure and your applications where things can go wrong. Sometimes those things are caused by you, sometimes they may not be caused by you or your team. But it's important to think of the everything here when you're thinking about resiliency and performance readiness. So there's a bunch of different topics we're going to go about here today. Brent's given me the heads up that we're running a little behind on time, so I have trimmed out some of the topics we're going to talk about in these each, but we'll talk about all 9 of them. But the slides that get posted will have kind of all of the context, so you will see some of the pieces that I've trimmed out, and I'm pretty sure there shouldn't be anything that looks like a gap. So we go through all of these here in order. So architecture design review, monitoring, logging, documentation, alerting, service level agreements, expected throughput, testing, and then deployment strategies, starting the top and kind of going on around through this. So let's kick off. So architecture design review. When we think about things like architecture design review, what we're typically thinking about is really just the visualization of what does your architecture look like? What are the components in your application? What are the components in your stack? What are the helper services? What services are you reliant on? And then thinking about, going back again to the key line that we have from Werner of everything failing all the time, is how can each of those things fail? How can communication fail between them? How do they completely go away? What is a degradation? What's acceptable? What's not? And so what you want to do then is think about, first of all, what the normal behavior is that you'd have. So what is my expected steady state? What is normal to me? There's always kind of that saying of, the developer calls you up and says the site is slow. Well, what is slow? How do we benchmark that against what not slow is? And then how do we decide then what we can do to diagnose that slow? Once you have some sort of steady state, then you can start to think about, well, how do I test for things being broken? Again, what is slow in this case? Is it one page? Is it one action? Is it the return of clicking on a form button or something similar? And so thinking about the various things that could happen that could break as part of your architecture, and thinking about how you can test it then. So coming up with some sort of a concept of an experimental group potentially that you would then simulate these failure situations against and being able to get back results. At the end of the day, when we do application monitoring, this is more or less exactly what we do. We create some sort of somewhat contrived application workflow or process or test. We test it against our infrastructure, and then we see if there's a difference versus the benchmark or the normal state of that versus whatever maybe comes back in the case of a failed test. And so really this concept of a design review and then how you think about testing your hypothesis of the failure is one of the core things that we actually do when we're monitoring software. We're testing to see if it is failing or not. Pretty straightforward. So some things that could fail, right? So you could have failure of a specific service in a specific location. And for us here at AWS, we give you availability zones inside of regions, and then we give you regions of which there are many across the globe. And so you have to think for you and for your business, do we need to be just multi-AZ, or do we have to be multi-region? What is the potential cost of a failure to an AZ versus historically how they've happened in the past, which is fairly rare. How are we going to be able to handle things like traffic spikes? So you've probably already heard a bunch today around things like auto-scaling, both with EC2 and containers. In the serverless space with Lambda, which I spent all my days on, you don't actually have to think so much about scaling. It's just going to happen as part of the platform. But for EC2 and for container space, how are you basically planning to handle scale? And then avoiding single points of failure. And this is one that I find that Often when I've worked with customers in the past and something unexpected happens and things go down or things go boom, single points of failure can very often be one of the things that has seen things gone wrong. In my past, actually, at one of the previous companies that I worked for, we had an issue on a weekend where some SSL certs expired on an internal management tool. And every host that we had inside of our infrastructure had that SSL cert. And so we needed to then go forward and update that SSL cert so that we could use our infrastructure management tool. And unfortunately, this infrastructure management tool became a single point of failure, not for our application, not for impacting our customers, but for our ability to actually impact and make any sort of change in our infrastructure. Needless to say, the getting around the broken SSL cert was actually significantly complicated, given that we had one general tool that provided all of our basically control plane access across our hosts. So single points of failure can represent themselves in more than just thinking about like databases or your hosts that serve customer traffic. Your own tooling can actually be a single point of failure towards things that you need to do. Another similar example, we had a network outage in one of the companies that I worked at that we had a single server that ran IRC for the company, and IRC was the main communication platform for us. Well, we had an outage in our data center. It took down our IRC host. We actually couldn't communicate internally to try to troubleshoot this. This resulted in a lot of texting, a bunch of people firing up Skype, which involved a lot of people creating Skype accounts because at the time they didn't have it. This was in a pre-Slack world. And so again, single points of failure represent themselves in many ways that you wouldn't expect. Thinking about how you can come up with things like standardized libraries, guidelines, et cetera, for your company to use is actually one interesting way to think about avoiding failure. So I've also been in a situation with an organization where we had multiple different programming languages internally. And it turned out that we would put people on call, and occasionally they would not necessarily be able to debug all of the logs from the various languages that we had. So actually this little bit of difference inside of our platform created effectively architectural availability concerns. Could we recover from an incident if people didn't understand all of the various parts of our stack? So thinking about design patterns, things as little as languages that are common across the platform. Thinking about places where you can implement design patterns, for example, for application tiers, always using auto-scaling, always using multiple AZs, making that kind of a default assumption inside of your business is a powerful way as well to kind of avoid these things. And then thinking about security as part of a best practice. So why would we talk about security when we're talking about architecture design? Well, at the end of the day, security is largely going to be based around architecture design. So based on the design of your architecture, where can you implement security controls? Where can you have things like, maybe if your company requires something like a firewall device or some sort of a security device that acts as an ingest point between different things. That's an architectural part of your planning just as much as it is a security part of your planning. And being aware of things such as making sure that you are defensively coding for SQL injections, cross-site scripting, and all the various other types of attack things that we have. Again, SQL injections and your potential for having to think about them are based around you using a SQL database, which is an architectural decision. So how do your architectural decisions, again, relate back to your security controls? And then lastly, one big part, and actually something that we do practically, I would say religiously at Amazon, is peer review of code. So actually at Amazon, before you can pretty much ever get code live for most of our products, it has to go through some form of peer review. Actually, before it even makes it into sometimes a test environment, many teams will require there to be some level of peer review. Now, if you're doing continuous delivery, continuous integration, and pushing in small batches, a peer review can be pretty painless. But it's still something that we consider to be very key to how we operate. Let's talk about monitoring next. So traditionally, for many organizations, when they think about monitoring, they monitor things at the service level. And they look at the individual components that they have. But what they might often forget is that the overall application, or basically end-to-end experience of your customers, is something that can be a lot more impactful to your users. One thing that I've had to teach people over time here at AWS is, if you're using things like auto-scaling, do you really care about high CPU? Probably not, given that that's going to be the kind of thing that triggers auto-scaling for your infrastructure. In the serverless world, which I'm part of, our compute product Lambda, you actually don't even have CPU metrics. It's not something you think about. And so, but what you do care about is the actual response or outcome of your application running. So what are your customers seeing, which is something, again, which is much more on the application level. Now, this doesn't mean that you don't do service level monitoring, but you want to think a little bit more about what are the things that you want to wake you up. Do you want something to wake you up that says, CPU load is high on a single server? Or do you want something that says the latency for our checkout process is 15% higher than it should be? So thinking about, again, things like application performance, understanding how the whole application is performing, understanding how certain calls to certain resources are performing. So maybe overall, in aggregate, your web pool's CPU is low. But again, maybe something like your cart process is much higher. Those are the kind of metrics that can sometimes kind of disappear into the forest of metrics that you have for standing out as something that you'd want to care about. Is there some sort of trend of things going up and down? So I've seen a number of monitoring metrics tools that make use of things like confidence bands. So sometimes it's not that a metric is too high, but could a metric be too low? And could that low thing be something that's impactful to you? I could say, for example, that at Amazon, on the retail side, we monitor both if purchases are higher or lower than they should be in a given period of time. And if we see that purchases per second go beyond a certain threshold, I can tell you that a whole lot of people get jumpy pretty quickly. Whereas if they also go higher than we would expect, is there some sort of an event happening? Is there some sort of social media event that happened or some sort of big announcement that would drive that? We want to inspect both of those to make sure there isn't some sort of false positive that we're not paying attention to. And then again, is it something like a specific part of the application that's generating an overwhelming majority of, say, errors versus just one component? And again, when you look at things like service level metrics, for example, looking at a web service in a cluster, you may not understand the individual application flow and individual application concerns. So when it comes to thinking about all of these metrics, one thing, again, that I'm talking about here is kind of starting with the metrics that exist first facing your customer, and then building back to the related system metrics that impact that. So is the site slow? What does slow mean for us? Are we seeing more failures of checkouts or logins or commenting or whatever it is that your application might be doing? Is there business logic components that are, again, slow, failing, not behaving in the way they should? Then try to tie that back to the individual service resources that are represented by that capability. Another important thing to be on top of is that averages hide issues. So you want to look at things like percentiles. Again, this is where things like confidence bands can be very useful, which most metrics and monitoring tools these days offer up. So again, you could have things that are hidden in the noise of all of the graphs and all of the averages. This is where percentiles become really important for you. An example of this, we can see here a graph where I'm graphing both the mean and median of latency of an application. We could say, well, this looks pretty good. This is under 100 milliseconds. That's a reasonable amount of latency for this application. It's fairly consistent over this window of time here, which is measured just in a number of hours. But this could be hiding more data than I'd expect. So for example, if we look at the 99th percentile, we can see that there are actually some huge, huge, huge pieces of latency that are spiking up. And so while this is not, again, going to be the experience of every customer, this is the experience of some percentage of our customers that is representing, an unhappy experience for them. And we could see this even if we went to, say, the 90th percentile, the 75th percentile, that might actually hover way above what we would expect it to be. And again, what we might be monitoring is part of a normal. So we'll often internally at Amazon have alarms that look at 99, 90th, 75th, and then something like mean or median, in order to understand kind of what percentage of our customers are experiencing what versus just the average. When it comes to thinking about how you do monitoring, I talked about this a little bit before in the fact that when we're testing our infrastructure, when we're actually doing traditional monitoring of our infrastructure, typically what we're doing is synthetic monitoring. So that's ping the site, make sure that something comes back within a reasonable time. That's maybe load a page and see what happens and make sure the resources load on it. But what's becoming ever kind of increasingly popular is this concept of real user monitoring. Sometimes this is agent-based, so maybe something that is living inside of a mobile application that's giving you back results to what you're doing. Sometimes this is JavaScript snippet of code that's running inside the browser that's telling you more about how your site and what it's doing. And so the benefit to this is that you're actually seeing a little bit more potentially things like workflows of how users are going from page to page or from action to action. And sometimes you're also seeing things that could be represented other places, such as DNS issues, traffic bottlenecks, the result of other things that are part of it. Example of this, at a place where I used to work, we included a third-party package that was actually supposed to help us do real user monitoring. And what happened was we started getting complaints that the site was getting really slow. And we looked on our server metrics and everything was great. We were serving up pages really fast. Everything was wonderful. But very quickly going and loading the page in a browser showed us that it wasn't at all representing what was happening from the end result of that page loading. Just so happened that the real user monitoring tool that we were using was experiencing a failure, and the JavaScript that we would embed into our pages couldn't reach out to their backend and complete what it had to do. Now in this case, we had made a mistake. We had made this JavaScript be something that blocked the rest of the page's rendering, as opposed to it being something that would load at the end. And so we learned a very valuable lesson about real user monitoring tools via basically the fact that we hadn't implemented one correctly. But again, it wasn't anything that tripped any alarms inside of our own infrastructure. Our servers were fine. Everything inside of our four walls worked just great. However, though, understanding from the perspective of the customer that things weren't right is a key important thing to do. Let's hop on to logging. So logging, some kind of pretty straightforward advice here. I don't always entirely agree with this, but I've been seeing more and more people to do it, so it seems to be kind of a growing trend that's just kind of taking weight. And it's the idea of writing logs using something like JSON. Basically taking your log file and adding structure to it that defines what it is. Where we're seeing this become more popular is that in more complicated architectures where you have lots of things generating logs, and you want to attempt to do some sort of level of log correlation, you might have an application server that generates logs one way, a web server that generates logs another way, systems level daemons that generate logs other ways, and doing any sort of cross-analysis on those can be really difficult if you just have raw text. So most logging engines just generate raw text. And so passing them into some sort of JSON structure, which then allows you to, again, be able to pull out the structure from them, can be really really beneficial. If you look at a lot of more recent logging tools, for example, like the Elk stack, they actually make it fairly trivial for you to generate JSON around your typically string-based log data. It makes it a lot more effective when you actually want to do queries on that data. So this, again, allows you to add context, allows you to understand a little bit more about what is actually in a log line versus, say, a long string that might be difficult to parse visually. And so thinking about adding some sort of structure to your logs can be really powerful. I also think, though, that it does add a bit of overhead in terms of the computation necessary to take those logs, pass them along, and process them. So JSON's not the most efficient, basically, language for describing or for wrapping logs. It does add more characters to it, so it will take up more storage. But again, the benefits sometimes can outweigh that. Here's another one that people don't often think about, timestamps. So pretty often people will create server infrastructure with whatever the timestamp is of the time zone that their team is based in. Well, if you work with any third-party services or you have people that exist in other geographies, this could be a huge pain. And then at some point, we have this little thing called daylight savings time in most countries that comes around and completely screws up everything because all of a sudden it jumps your logs 1 hour forward or 1 hour back. And so UTC, essentially the standard central time, is always the best guidance for what time your service should be in. It does mean that twice a year you have to mentally remap yourself to what time your servers are based in. However, this will give you consistency over long term for your timestamps and your logs. Another thing is, wherever possible, you want to have as much data in this timestamp as you can. So don't just do things like hour minute or even hour minute second. Wherever you can, you want to get down into the microseconds. In AWS Lambda, for example, we bill in the hundreds of microseconds for that product. And we have many services or many executions of Lambda that take even less than that. So when you're doing tracing inside of a Lambda function, you're often doing sub-millisecond tracing for what it is that your process is doing. And so it becomes really important to have this type of depth to the data of just the timestamp to be able to do ordering of events inside of that.
Why twice a year?
Hmm?
Why twice a year?
Twice a year because you've got daylight savings coming and going.
That's universal.
No. Talking about how like you mentally, your time zone that you're thinking about. So if we know that UTC is off by 5 hours for part of the year and then it's off by 6 hours for the rest of the year, just saying that like when you're looking at your own logs, you have to think about why they jump. Yeah. Servers stay consistent, our brains jump.
How do you deal with like services that you want to run at local time zone, like the cron for example?
Mm-hmm.
Your service you just need to want to send an email every day at like 10 p.m.
Yeah, it becomes one of those things that you do have to keep on top of the fact that it shifts.
So you have to do have any like automatic things?
I think a number of like if you're using a third party for that, they'll typically allow you to schedule it and they'll typically take care of that for you. But whenever I've done it and I've used UTC for a long time, basically when it's coming around, I just know that I need to change that cron job. Yeah. Cool. Another thing about logging that's really important is this idea of transaction or correlation IDs. And basically where this can be really useful, and this is a good thing to structure inside of like JSON structured log information, is the ability for you to trace that a request came from point A to point B in your infrastructure. Now we actually have a product called AWS X-Ray today that actually can do this for you to a degree, where it generates a event ID and basically gives you the way to pass it through various parts of your stack. But if you aren't using that or it's not supported in some piece of technology that you're using, generating an event kind of at the ingest point of your application and then passing it through can be really useful. And so actually today, I think all of our ELB products or all of our load balancing products generate a Amazon ID that you can use. So we generate kind of a UUID that you can use yourself. Or you could just in your own application generate some sort of unique string. And I would recommend that you don't just use like a random integer, an incrementing integer, but you do look at some sort of UUID type structure so that it is more random and you don't have to worry about collisions with that. So lastly here about logging is around documentation. So kind of an odd one to think in relation to your logging, but when it comes to understanding what to do about logs and failures in logs, documentation is the #1 kind of source for figuring out what it is. Internally at Amazon, every service team will have a sophisticated amount of documentation that they've written for their internal processes. What their tools do, how do you use them, a history of like big product changes that they've made, and they'll effectively have what we would consider internally a run book for recovery from failures or what to do if you see certain failures. And so documentation becomes kind of the living log of your code. And so again, keeping this close to your code can be really useful. So maybe either better embedding it in your code as like a README, or again, using something like an internal wiki, and just trying to make sure that teams keep that up to date, which can be a challenge, is really, really key. So again, how do you install your software? How do you configure it? How do you troubleshoot it? So next we'll talk about alerting. So we talked about monitoring, which is basically kind of looking at things to see if they go boom. The reaction to that is alerting. So things went boom, now we're going to do something. There's a lot of different tools that exist out there for doing alarming. Kind of a full world of open source things, enterprise things, hosted solutions that are out there. We see here an example from Monnet, that's what this wonderful little bulldog guy is, of kind of a process check command that's looking at a PID or a process identifier for Nginx, and what happens if that goes boom. Basically, this gives me the ability to start and stop that program based on that, and then the group identifier for it. Now, lots of different tools, lots of different ways to think about it. This is one of those things that I say, whenever you can, give it to somebody else to deal with. So managing and running your own monitoring software, there's little benefit to you doing that. At the end of the day, there's established platforms like Datadog, for example, that will do this much better than you will and save you a whole lot of time and be worth every penny that you spend on them. And there's a number of different solutions that exist out there. But sometimes what you want to do is actually not have to alert on a failure. So for example, in EC2, we have something that we launched a little while back called auto recovery. What this does basically is it looks at certain system checks or certain issues that might exist on the instance when it becomes unavailable. And what it will actually do is take that instance, detach the storage from it, and restart it back on another host. So why alarm on something if you can just automatically recover for it? Now, you do want to a degree, make note of this somewhere. You want this to be logged, and you want to track that it happened, so you don't have a service that's just continuously restarting nonstop all day. That would be bad. And again, this is where those application monitoring that we talked about before would come in. Another thing is auto-scaling. So I'm personally pretty religious about this, the idea that you should never have an alert that says that you have high CPU. You should never have an alert that says that you're running out of memory. You should never have an alert that says you're running out of storage, with the exception of things like databases. But for everything else that looks like a web server or an application server, all of these things can be solved with auto-scaling in AWS. There's really no reason for you to get an alarm ever that says the CPU is high. We give you, again, near infinite capabilities to scale in the cloud. Make use of it. So auto-scaling, very basic kind of an example here of a configuration. I've got a desired count of 1, a min of 1, a max of 5. I can make that much larger if I wanted to. You can see my health check configuration. So basically it looks at EC2 health. And then the grace period is basically how long to wait after I start a new instance. And then it basically goes ahead and has a couple other things. In this case, just a cooldown, how long I should wait in between triggering things. And so between auto recovery and auto scaling, you really shouldn't have to care about your individual hosts. That's really kind of the idea of what we go for here. You want to, as much as possible, allow these tools to take care of some of the operational burden of you caring about your servers. However, there will be times when things go boom and people do have to react. You can't auto-scale your way out of something. You can't auto-recover your way out of something. So what can you do? So a number of different tools exist out there for alerting. Our CloudWatch alarms are actually fairly basic. They don't have any ability of escalation like we're showing here. They don't have any concept of rotating, but this is where tools like PagerDuty and VictorOps and others come really useful, and there are certain open source ones that will help you with this as well. And you want to think about kind of a structure to this, so having a primary, a secondary, escalation up to a team, escalation up to eventually management of this team, if there isn't response, or at least response within time. Had an issue once at a company where I worked where the person who was on call, we had such a busy on-call week that they didn't realize that while they were sleeping, this was back in the day when people had these things, their BlackBerry died while they were asleep. That's problematic when you are on call and your BlackBerry goes off when things go boom. And so in this case, this person's BlackBerry had died, and they missed the page that came to them in the middle of the night. But luckily, we had an escalation policy where after a certain amount of time, the secondary got it. And so in this case, the secondary was able to wake up and respond to it. We had a little bit of an issue where for several hours until the morning, we weren't able to get in touch with the primary, and there were some concerns about what might have happened to them and if they were healthy. So the first lesson is always plug in your stuff if you're on call and make sure it's charged. The second is make sure that you have some sort of strategy for handling things like, hey, someone's battery or their phone died or what have you. Let's talk a little bit here about service level agreements. Brent's staring at me and I'm running a little long, Brent. Trying. So service level agreements or objectives are often things that customers of AWS ask us for. And at the end of the day, an SLA from a business perspective can be a legal or contractual obligation, which means many things. But internally for us at Amazon, what we pretty much always have are SLA or SLOs at our service level internally. In fact, I don't know of a single service that does not have some sort of SLA or SLO goal that they are tracking to the point where every week we respond to it or we report on it. And so you want to think about kind of what these mean for you and your business and what they mean across the various capabilities that you have. So for example, can your search have lower availability than your cart? Well, search going down might be problematic, but cart going down means you can't make money. And things like avatars, so showing you the images of people when they're in your, say, your forums or comments, not showing up could be even less important. So in a modern world today where people are building microservices or at least more service-oriented architectures, can you actually have different levels for these and different acceptance ratios for where you think about a failure? Again, for thinking about how this ties into monitoring and alerting, we might have a way lower acceptance of errors for the cart than we might for the avatar service. And when you actually think about nines, people say, well, I want all the nines I can have. These can actually be fairly unreasonable to think about. So again, everything fails all the time. Things are going to fail. Let's say that we internally take some sort of SLA that says that we're going to have 6 nines of availability. So 6 nines of availability means that per year, we will have 31.5 seconds of downtime. Now, where this becomes problematic is when you start thinking about how you recover from failure, right? So if we want to recover from failure, and let's say we were going to say that we were going to do a multi-region application. So multi-region application, we're going to fail over between it. Typically, a health check that you do, any sort of health check, is going to take more than a minute's worth of pings against the service to detect that something is down. So you might be 2, 3, or more minutes before you understand that something is down, so you could do something like change DNS. DNS might, on many systems, have something like a minimum 1-minute TTL. So all of a sudden, you're at 5+ minutes, potentially, of downtime for a service, just in order for your automated systems to react, recover, and respond to it. So we've already kind of breached our 6 nines SLA. So you want to be reasonable about these things. Things like 4 nines actually make a lot more sense if you were to think about failure and recovery. Less than an hour of downtime per year is a pretty damn good goal. And so I think that this is the kind of thing that makes a lot more sense than going down to this. Again, it's really, really difficult to architect for 6 nines of availability. And most businesses don't really need that high of a level of availability to begin with. If you do, this is where you start to think about things like having multi-regions where they're hot, where you're basically pushing the redundancy all the way up to the edge of the internet, making sure that traffic is always going to various locations. And then what you're not thinking about is a complete outage, but a potential for disruption for some percentage of your customer base. But that's a very complicated thing that would have to have very specific business needs. Again, we talked about this a little bit here. It's important to know whether things seem slow or not, but it's also important to know about things like throughput. So for example, understanding kind of what the breakpoints are of your application. How much concurrency can we handle at a certain level before our database goes down? So this is something that we see in the serverless space a lot, where with Lambda, it just automatically scales for you. It's wonderful. You throw requests at it, it goes and scales. Challenge that some of our customers have is that Lambda application might be talking to a relational database that doesn't have that elasticity. In fact, the concurrency that it might have might be considerably less than the concurrency throughput of Lambda. So this becomes kind of a challenge for thinking about, well, now I have to think about potentially scaling my database much more than the potential for my application tier. And so how do I want to react to that? So we talk here a little bit about number of instances, at kind of like the low point. So what is the minimum number of instances that you need, understanding averages, and understanding how the failure of that reacts. This actually also becomes really important when you think about auto-scaling. So if you're going to do things like auto-scaling, let's say you have a fleet of 80 hosts. And let's say that you have a trigger where when the CPU is above 75% for 15 minutes, add more capacity. Well, do you want to add 1 host, 2 hosts, 10 hosts? That's actually something you want to think about given the amount of time that it might take for those hosts to spin up and join that pool and become active versus the extra capacity that they actually add for you. Almost done here. So testing. So thinking about testing, obviously very important from a performance perspective, from an availability perspective, and really things, kind of everything that you're going to want to focus on from the testing perspective lends itself back to that as well. So we've got kind of here the continuous integration and delivery loop that people like to throw up. Now there's this concept in the industry of what's called test-driven development. It's another one of these things that some people love it, some people hate it, and there's a bit of back and forth over whether or not it's a thing to do or not. Just to kind of explain exactly what it is, it's basically the idea that you are going to build effectively a business or capability-focused test. This function will do this thing. And then what you're going to do is write the functionality against it. So you're literally writing the test cases for your business application logic and then making sure that the application meets those constraints. Now, what's interesting is that one of the caveats to this is that it really requires you to write really strong, smart tests. And so this could be problematic for lots of reasons because you have to, in your test cases, potentially think ahead of time of all sorts of potential needs of your application. So some people will say, well, this slows down my development process. This makes it take way longer for me to be able to develop applications versus building tests reactively. What's great about this, though, is it gives you a common baseline for how you could think about your application's performance and its capabilities. And so if you do it the other way, where you don't have that established baseline and you make code changes, it could become much harder to find bugs a long time. And lastly here, deployment strategy. So one quick thing here on deployment strategy, one thing that people often don't think about is database migrations. So I personally really strongly dislike what Ruby on Rails did to the industry by making people think that they should tie database migrations into deployments. It's something that got very much popularized with a lot of the Ruby on Rails tools that were out there. And now people think that this is a good idea. It's actually a really, really horrible idea. When I worked at Etsy, we actually had completely separated out our application deployments from our databases. Database changes to the fact where we basically had something that we called schema change Thursday. Surprisingly enough, this is when we made schema changes on a Thursday. And it was a window of hour of time every week. And basically developers had until Tuesday at 6 p.m. to get in the suggestions or the changes that they needed in the database. They would get reviewed on Wednesday by the operations team. And then a member of the operations team every Thursday would go and apply those. And we had various tools to help us with our databases. And what this did was kind of help us, control what changes were being made, because we were practicing continuous integration and delivery at Etsy, where 40 to 50 times a day our primary product got deployed to. But this also kind of helped control aspects around the quality of these changes. So for example, one thing that we implemented was that we would never remove a column. We would only do additions to our database. We would also never change the type of a column, not while it was live. And so when you operate in this model, it helps reduce risk. It also helps with kind of overall stability of the database storing these changes. And for an e-commerce shop, we were pretty much 24/7. We didn't have the option to turn the site off and make these changes. So one of the benefits that you have now to cloud, so we at Etsy did this on physical hardware, is that you can very easily in AWS with almost all of our database systems, clone your database, bring it over kind of to a development or staging environment, test your changes, and understand what's going to happen. You also have a really easy ability these days to do snapshots of RDS and Aurora and Redshift and DynamoDB. And so if you do happen to make a bad change, you can kind of easily unwrap that. So in terms of deployment strategies, there are a couple different concepts out there. We talk here about canary pools. Sometimes this will be talked about as blue-green. Some people call it red-black. All three of them actually do technically mean different things, but at this point in the industry, they've all been kind of merged into one big kind of blob of understanding, which is the idea that you basically have version 1 of your site, and at some point you deploy version 2, and what you want to do is shift some traffic over to that. Now that can happen via load balancer configurations. It can happen via DNS. We actually just last week announced that we'll be launching capabilities in Lambda to do this via something actually called traffic shifting. And so what's great about this is in most situations you could push that out to some percentage of your traffic, test it for some period of time, either via actual traffic, maybe synthetic traffic that you run against it, and then if things look good, push it out maybe just a little bit more or completely flip it out to everyone. And so this gives you, again, the benefit of being able to test a little bit what you're doing before you push it all the way out there. At Amazon, we actually have a concept called one box. And much like it sounds, it's the idea of pushing your code out to a single box that is part of a production fleet that is getting traffic. And then we have more monitoring on that one box than we do necessarily an average on everything else. So we look at the metrics just a little bit more in depth than we look at it across the bigger pool. And so basically that's a form of canarying where you have this idea of this, canary in a coal mine, where if something bad happens to it, then we know that we've made a change to our application that is a problem, and we should unwrap it. So blue-green, really common model. This concept of canary pools or one-boxing or whatever you want to call it, also pretty common. But basically the idea that you're just not going to throw your code out over the fence to all of your users at once. It's pretty poor form to do that. Another key thing when it comes to thinking about deployment strategy is concepts around either dark deploys or feature flags. So when I worked, again at Etsy, the story that I'll use here, actually I'll bring it to something in Amazon here. So very often we launch new features or capabilities. Internally, we've been testing them and accessing them for a while. So just today I got to play with something that is launching at reInvent that in a few weeks you will all learn about that you don't know about now, and I do, and ha ha ha, but say again? I can't tell you what it's called. It's pretty cool. And so basically, this was the ability for me to be opted into this capability. And eventually, we will open up that opt-in flag, and everyone will get access to it. And so there's lots of different things that could happen here. A/B tests. For a little while in the S3 console, we were A/B testing out different versions of that console. And actually, people picked up on, oh, there's changes here. And they started taking screenshots, and people saw that their screenshots were different from other people. And what were we doing? Trying to figure out the best capabilities and the best look and feel for that console. So lots of different benefits to these. There's actually a number of different products that exist out in the market today. Do not build your own feature flag system. Zero benefit to you. Use one of these libraries or one of these third-party products to do this for you. It's definitely going to be worth your time. So, as again, I'm the key person keeping you from drinks and happiness. Just kind of in summary today, we went through 9 topics really, really quick. Operational preparedness or production readiness is a big topic that people spend their entire careers on. 9 major kind of areas to think about: architecture, design, review. All right, kind of looking at the architecture, figuring out those single points of failure, asking what happens if each of these components breaks. Monitoring, so actually understanding not just, again, things like CPU load is high, but what are my customers experiencing? What pain points are they seeing that I may not be able to detect? Logging, so gathering detailed information, standardize the format, use UTC. Those are kind of the 2 main guidelines today. Documentation, making sure that your team has understanding of what it is that you've built and how to operate it and how to run it. We like to sometimes talk about the bus count. It's basically how many people on your team could die in a bus accident where the business wouldn't be able to recover from it, right? You want that number to be really large. You want the idea that a bunch of people could disappear tomorrow, but you could still figure out how to operate your product. Alerting, so understanding what should happen when things break, how to avoid it. So maybe do we not even to alert on something that we could auto-recover or auto-scale about. If you are going to alert, make sure that you've prevented the battery dying in the middle of the night situation. Service level agreements, so again, understanding what makes sense for you as an organization to take as a target. Expected throughput, so are things high, are things low, are things faster than they should be or not? Doing testing, and then lastly, deployment strategies. So a bunch of things to cover here, a bunch of resources that you can read more about this. The production readiness review that exists up there from Arvix is pretty cool. Netflix has a number of tools. Feature flags. We didn't cover error budgets. I actually didn't get to that here in the slides that I presented, but they'll be in the slides that are posted. And then monitoring philosophies, which there should be dozens and dozens of links about that. Okay, my name is Chris Munns. I'm Senior Developer Advocate for Serverless here at AWS, based here in New York City. You can find me at munns@amazon.com or at Chris Munns on Twitter. Happy to take some questions, but then like everyone else, I'm going to step outside here and hopefully enjoy the happy hour.
Sorry, I was actually going to suggest that maybe we adjourn, and then Chris will be out at happy hour, able to answer questions over a beer. Much more relaxed, and I'll be out there as well, and I'm able to answer similar questions. Cool. Thanks, guys.
Thank you.